Welcome to this Model Railway Electrics video. Since 2014 I've been using the excellent Morley Vector Zero 2 controller, and a most reliable and flexible controller it's been. As some may know, it's been modified to improve slow running and has been absolutely hammered for the last 7 years. It's now in need of a clean-up and gentle service, and I have a further modification I want to try, while at the same time my Gaugemaster Model D has been sitting idle for a few years now. I also wanted to add some analogue ammeters to the railway so I could see how the models were doing electrically, and of course I would still want the facility for handheld use when filming, etc. Therefore I also purchased a further Gaugemaster Model W to go with my venerable one dating from 2007. So I started to draw up plans for a control and switch box that would allow me to switch between the Model D and the two handheld units, as well as house the ammeters and, very importantly, tidy up all the external wiring by incorporating the Gaugemaster HF2 track maintainer and an isolation switch for the same. And there were many plans, many plans, working out the required facilities, likely connections and implications. Plan after plan. So what did all this mean? Well, first of all, I had to find a project box from among my previously used stock. Then I had to fit 2 ammeters to this. Got these from eBay via China. Yes, it took 3 weeks to arrive, but they cost me just a few pounds each. They are 1 amp range, middle zero, so that they deflect left and right of centre, giving the positive or negative current reading. Then I started laying out the other components ready for drilling. I decided I wanted a nice power on LED between the ammeters, and a small bridge rectifier circuit was built to supply this, as well as another yellow LED to indicate the HF2 was switched on or not. The HF2 was going to be fitted on the lid towards the back, however its terminals point downwards, so I had to drill small cable holes in the lid so that they could feed into it. Next came the all-important rear terminals for the new box. I decided on these 3 amp chop block types and had worked out that I needed 17 external connections, so added 18 as a spare. In the event I only needed 16, giving me 2 spares for the future. The chop blocks were fixed from the inside of the box with small self-tapping screws. Now wiring could start. I had already extended the wires on my Model Ws with some 4-core alarm cable, and was able to use this and the original cables from the Ws to make the internal connections. I also had some 6-core cable that would be used from the Model D to the control box, keeping with all the colour codes of the wires made things much simpler. Using A4 self-adhesive paper, I made some labels to identify all the connections referenced to my plans. Well, hello. Finally, all the hardware on the box is done, and it's time now to get the Model D out and start wiring up the internals of the box. That's the first thing. I've still got to fit the DIN socket and plugs to these. Drill a hole in the boards to take the DIN sockets and plugs. But first of all, we're going to try and do all the internal wiring, and we'll try and observe colour coding and use 4- and 6-way cables wherever possible. So let's crack on. For the Model Ws, I was able to use the original Gaugemaster wiring plan for the DIN plugs and sockets that I had purchased. Speaking of fitting DIN sockets, it was going to be necessary to cut a slot in my backseam board to allow for this, as the sockets were being fitted near the halfway point on the back edge of the layout. By the way, sorry about the huffing and puffing in the video clips, I've been rather unwell of late. Welcome to a very wet day at Model Railways Unlimited. So, things have been happening. The conversion is complete. The Model D is powered up, ready to go. The ammeter control box is all set up. And as you saw when we were building it, that switch is to turn off the HF2. You get the little yellow light there. Turn it off for cordless motors. And then we've got the ammeters to tell us how much each loco or each track is being fed with current. And we'll just have a look at the back of the box where all the connections are, and not quite as neat as it was looking, but it's not too bad. Bear in mind it's a portable layout. The wires go off to the other side there to the handheld units, but it's all wired in nonetheless, and I have my point motor being controlled by AC this time instead of the DC that the Morley used to provide. No problem with that whatsoever. So let's have a look at it working. So the selectors are, if the camera would focus, selectors are select to Model D. It's just there. Focus is dreadful. And we have a Dad built 700, which, as you can see and you would expect with Gaugemaster, creeps away nicely. Now then, the difference is we can see she's drawing around about 200 milliamps, which isn't bad at all for the open frame motor that she's got. Now if I change direction, you see it deflects the other way. Fractionally more current, but way below the half amp there. The 0.5 is your half amp, and here she comes, no problem at all. So now we've got the Bachmann 3MT on the outer line, which is on track 2 on the Gaugemaster, and we set her off. And obviously we're on this meter now, but look at that. Fractionally less than 100 milliamps, and that's with a load, which is pretty good and what you'd expect. We'll just see her come round as well. Sorry about the handheld work, no way to do otherwise, I'm afraid. And we're also on the auto settings on the camera, which I don't like. Its focus is horrible, and depth of field probably not good. Anyway, there goes the two trains. Now, in controller world, two controllers must never ever meet electrically, otherwise you'll get smoke and expensive repairs. So in order to use the handhelds, that's what these switches have all been about and why it's been so complicated. They're the changeovers. So if I do that for both, switch it up to the handhelds, and now it won't matter what I do on the Gaugemaster, trains don't move. That controller is now totally isolated. But if you come with me, you saw where I was fitting them. And we'll take hold of track 1 outer first of all. Sorry, track 2 outer. Handheld. And turn him. And off goes the 3MT. This time working on the handheld. And we also get an ammeter reading. So when I'm filming, I can get all the way around the layout now, so that I keep out of shot and I can concentrate on what I'm trying to present to you, rather than running back and forward to the controller. And Morley also did this, but its wires emerged from its control unit, which meant they were always dragging away from where you had to go, whereas now I'm completely free to walk all the way around without a problem. So that's the outer. As we go on to track 1, which is going to be the more complicated ones, where most of the shunting is done, purely because it controls the yard. I do wish this camera would focus. Anyway, so now power her up and round comes a 700. Nice bright LED. This is my original walkabout. The other one I purchased on eBay. It was new in the box, but it was a newer model and there was a slight difference in the build quality. Nothing too much to worry about. So there we are, and we've got the ammeter deflection as well. That is my new control box, finally finished. So there we are whilst that tests for a little bit. There's a lot of reinventing the wheel where it comes to controllers. Certainly DC controllers, I accept that DCC is different. I've tested many now, and you've seen I've built one myself and I'm quite happy with that, but basically that follows the Gaugemaster pattern. I've also done some extensive testing on pulse width modulated controllers, but the type where you can vary the frequency, which is all important because that's what can do the damage. And whilst I had some interesting results with them, none of them could produce the quality of running that the simple Gaugemaster handheld or Model D can do. And it struck me that the motors, even the cordless motors that we see today, were all designed some years ago. They are in fact quite simple. They're a moving coil or core in a magnetic field. And in order to get a really good performance, if you select really good quality components, as found on the Gaugemaster controllers, and you deploy them neatly and thoughtfully, then you will get good running just using full wave rectification, giving you 100 Hz sine wave, which is absolutely perfect for our motors. They don't get hot, they don't burn out, but they perform exceptionally. So for me, that's the end of my experiments. Not to say I won't play with a pulse width modulated controller at a later date, but that's the end of my experiments. I've switched over to Gaugemaster. The Morley is away for a clean up and a couple of changes to make it even more Gaugemaster like. Go down to 10 microfarad now instead of the 33. And well, maybe you'll notice a difference on future videos. I don't know. Hope so. I'm certainly very pleased with the way this has turned out. It's been a good and interesting exercise. Cheers for now.